It turns out that most of our measuring devices used to measure pressure don't actually measure absolute pressure. They measure something called gauge pressure. Gauge pressure is essentially the pressure in excess of 1 atmosphere. So if you used a pressure measurement device, and we'll talk about some in just a moment, to measure the air pressure around you, it would show 0. Doesn't mean there's no air around you. This doesn't mean that you're not experiencing pressure. You're experiencing 1 atmosphere of pressure. But the gauges measure how far off that 1 atmosphere of pressure your particular container or whatnot might be. Gauge pressure is the absolute pressure minus 1 atmosphere, or 101,300 pascals. Now let's take a look at some measuring devices for measuring pressure. The first one we'll go through and examine is known as a manometer. This device has a box of gas at some pressure, and connected to this box is a U-shaped tube with some liquid inside of it. Now, this tube is open to the air on one end and connected directly to the gas under pressure inside the box at the other end. If we look at points 1 and 2, they're along a horizontal line, so we know that those two pressures must be equal to each other. If we want to go through and figure out what that pressure is, we can examine the mechanics of this particular scenario. The pressure at point 2, we can use our pressure equation we had before. The pressure at the top of the tube is open to the open air, so we have P naught, plus the pressure due to the liquid inside of the tube itself. So that's rho g h, where h is the height of the liquid. P1 is just going to be equal to the pressure of the gas inside the box. Setting these two equal to each other, because they're on that horizontal line and those two pressures must be equal, we can go through and solve for the pressure that's in the box. We know what the atmospheric pressure is. We can measure how high the liquid is inside the tube, and therefore we can determine the pressure inside of the box. Let's put some numbers to this. Let's imagine that we have mercury inside of this tube, and that the height of mercury in this tube is 36.2 centimeters. We can look on our table to see that the density of mercury is 13,600 kilograms per meters cubed. Using these values, converting to the appropriate units, of course, we can find that the pressure of the gas inside of the box in our particular scenario is equal to 149.5 kilopascals. Now, if we're reading a gauge for this, the gauge again is the absolute pressure minus 1 atmosphere. So 1 atmosphere is 101.3 kilopascals. So the gauge would read 48.2 kilopascals, or 0.476 atmospheres. Now this device can measure the gas pressure inside the box even if the opposite situation is true, if that pressure is less than 1 atmosphere. Now if that were the case, then the water or liquid line inside the U-shaped tube would be higher on the end next to the box and lower on the end open to the air. So we'll draw this in a little bit, making the liquid level higher on the left-hand side and imagining that the level was lower on the right-hand side. So now, if we go through and examine the pressure at points 1 and 2, we now have a height of liquid above point 1. So our pressure, and at point 2, it's just air. So point 2 is going to be equal to the atmospheric pressure. And point 1 will be the pressure of whatever the gas is, plus the density of our liquid times G times the extra height above 0.1. These two pressures still need to be equal, so we can set them equal and then solve for the pressure of the gas, which now will be the atmospheric pressure minus rho GH. And that's because the extra liquid is on the side with the gas, not the side open to the air. Our next device is going to be a barometer. Barometers are used to measure atmospheric pressure and are very important for weather predictions, like whether or not a high pressure system or a low pressure system is coming. Low pressure systems and high pressure systems are what determine our local weather around here. So let's use our rules for pressure to see how a barometer works. So you can make a simple barometer by taking a tube, filling it with a liquid, sealing it, and then inverting it into a dish. And by doing that, you'll create a vacuum at the top of that tube once it's inverted. Since the dish is open to the air, which we can see at 0.1, it's open to the atmosphere, so the pressure at that point must be the pressure of whatever the atmosphere happens to be. 0.2, however, is going to be equal to just the pressure due to the liquid on top of it. There is no atmospheric pressure on top of it because it's a vacuum above there and it's a closed tube. So P2 would just be the density of whatever the liquid is times G times H. Now these two need to be equal because they're along a horizontal line. So basically what this means is that the pressure of the atmosphere is going to be directly related to the height of that liquid. And as the pressure changes, we'll see that height rise and fall. So this is one of the reasons why when we go through and look at the different ways that units that people will use to measure pressure, we already have pascals and atmospheres that we've talked about. But additional ones that people use are millimeters of mercury. And this is precisely because of barometers. Old barometers used to be used with mercury as the liquid. And so by measuring the pressure in terms of a distance, a height, they were essentially doing this conversion for themselves. This atmospheric pressure is equal to the density of the liquid times G times H. You'll also see inches of mercury as well. The differences between the metric and the imperial systems. And then another common one that you've probably come across is pounds per square inch. So that's using the formal definition of pressure, force over area. So depending on what and whom you're talking to, they may use different units of pressure. But when you're doing your calculations, always, always, always convert to pascals before you go through and plug in your numbers.